Okay, so here we are back again for question number 4, part 2 of our continuation of product and quotient rule. In this one, we want to again determine where the points of this function have horizontal tangents. Now, if you notice, it's going to be very similar to number 3. So once again, we're really looking for where that slope is 0. So we have to take the derivative. Now, this time, however, we have to use our quotient rule when we're looking for that derivative. So let's go and take a look at that derivative. So to get f prime of x, we would use low x minus 1 times the derivative of the top, which is just my power rule, minus the top function x squared times the derivative of the bottom over the bottom squared. Now, one thing I forgot to point out, remember, the difference is between here, for number 3, all we need to find were those critical numbers. But for number 4, we want the points. Remember, we need x and y here. So right now, we're just looking for the x values where the slope is 0. Then we have to find the y values later on. Okay, now, because I am actually applying the derivative, normally I would just leave it like this. But because I am applying the derivative here, I will simplify it. Typically, we don't really like to simplify much in calculus, but if you're applying it, it does make it a little bit easier. So, looking at the top, we would get 2x squared minus 2x minus x squared over, don't distribute, just leave it x minus 1 squared. And that becomes, what's that? X squared minus 2x over x minus 1 squared. You don't necessarily have to do this, but because I am, again, applying it, it does make it a little bit easier for us. Now we're going to set that derivative equal to 0. Remember, we call those critical numbers. This is where that slope is 0. There's another type of critical number, too, where the slope does not exist. We'll talk about that in the next unit, though. So to get our critical number, we're going to set the derivative equal to 0. That's what I'm looking for. X squared minus 2x over x minus 1 squared. And hopefully you kind of realize we don't really care much about the denominator, because if I cross multiply, that's 0 times x minus 1 squared, which is just 0. So what we're left with is just 0, x squared minus 2x. Factor out your x, and we get x minus 2 equals 0. And our critical numbers are 0 and x equals 2. These are our critical numbers. Now look how organized I am. Take a look here. From left to right, my derivative, find my critical numbers, and now the last step is now we're looking for the points. I have x equals 0, and I have x equals 2. I plug these into the original function. I'm going to use f of x here. Let me block that off there. So I'm going to plug 0 in, f of 0, and this doesn't take any rocket science. 0 squared over 0 minus 1, that's just 0. So our first critical number is at 0, 0. And then plug in 2. I want to find f of 2. Remember, I'm going to plug it into the OG. So 2 squared is 4 over 2 minus 1. So f of 2 is 4. So my second critical point is 2, 4. And we actually call these critical points. Remember, a critical number is where the slope is 0. A critical point is the actual point itself. But these are our horizontal tangents. Now later on, we're going to find vertical tangents. And that's basically looking for where the denominator is 0. We'll talk about that later on, though. That's the secret for us right now. Okay? Okay, so perfect. You guys are doing beautifully. So let's go on to the next page here. Next question. This is question number 5. Now this is just something to kind of get us ready for. We really just want to take a look at a definition real quick. And that's the word differential equation. Now we know what differential means. This means that the derivative does exist. So an equation containing at least one derivative is called a differential equation. So this is just an equation that has a derivative in it. We're going to talk a lot about these this year, and next year in multi, we spend like a semester on these basically. Verify that the function y equals 3x squared minus 2x satisfies this differential equation. So if you notice, we have two derivatives in this equation, y double prime, which is the second derivative, y prime. So what we're trying to prove that the entire left side equals the right side. Okay? Now, if you go to college, there's a whole class that's called DiffyQ. If you have an older brother or sister taking it, ask them about DiffyQ. Take DiffyQ. It's fun. It's a good class. Actually, one of the more, that's a pretty exciting class. So, what we know is we are going to need the second and first derivatives. So, I'm going to go ahead and find the first derivative. They already gave me the function. So, my first derivative is power rule, 6x. Well, look, if you do it right, you will have 6x minus 2. The second derivative is 6, and, just for fun, let's take the third derivative. We get 0. Now, hopefully you remember what we call this. Remember, this has nothing to do with our problem. This is just free. We call this the Derivative Annihilator. Remember we talked about the Derivative Annihilator, right? You've been annihilated. So one thing I think Arnold should teach a calculus course and a movie and just call him, he's a derivative annihilator. You've been annihilated. It's just basically when the derivative becomes 0, we can't take the derivative anymore. Alright, so anyways, that has nothing to do with our problem. So if I write out my differential equation, x squared y double prime minus x y prime plus y equals 3x squared, I'm just going to plug these in. So I would get x squared times y double prime, 6 minus x times y prime, 6x minus 2, plus y, which is my OG, 3x squared minus 2x, I should put that in parentheses because I'm subbing in, equals 3x squared. Remember, I'm never going to touch this side. I'm never going to touch the right side. We only mess with the left side. So this gives me 6x squared minus 6x squared plus 2x plus 3x squared minus 2x, and I want to see if that's equal to 3x squared. And hopefully you see that. X squareds cancel, these 2x's cancel, and I'm just left with this 3x squared. So I just go 3x squared equals 3x squared. Don't simplify anymore. This is all we were trying to prove. The old Greeks used to say QED. It's the oblique, 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 oblique. That's all, folks. If you say 0 equals 0, that is true, but it's not what we're trying to prove. Don't go any further than that. All right, we're not going to worry about number 6 just yet. This is what's called a related rate. We're going to do these later on, so I'm not too stressed about this right now. So let's talk about that at a later date. But let's go to number 7. Okay, this is how the AP likes to ask product and quotient rules and everything. So it says, use a graph of f and h. Whoops, I forgot to put f on there. F is the top function. There we go. To find the derivative of h of x equals f of x times g of x. So let's see here. So here we go. We want h of x equals f of x times g of x. So we want to find h prime of 4. Well, so the first thing we need the derivative. And because we're multiplying, this is our product rule. Hopefully remember the product rule. We're going to take our first function, multiply by the derivative of the second. So f of x times g prime of x plus the second g of x times the derivative of the first f prime of x. So there's our derivative. And now what I'm going to do is for number 1, I'm going to plug in a 4. Everywhere I see an x, I plug in a 4. So I want f of 4 times g prime of 4 plus g of 4 times f prime of 4. Sorry, hiccup there. So we're just going to plug in. Well, notice this is f of 4, but there's no prime, so they want the value of f at 4. Here they want the slope of g at 4, the value of g at 4, and then they want the slope of f at 4. So let's go ahead and try this. So here's 4 right there. Here's 4. So there's f. I want the value of f at 4. So if I look at the value, f4, f appears to be 1. About 1. I'm going to guess that. G prime is the slope. So if that's the slope here, it looks horizontal. So the slope there looks 0. So I'm going to take that 1, multiply it by 0. Next, now I'm going to take the value of g at 4. So remember, this is my g function. The value goes to the y. That's going to be 8. And then I want the slope of f at 4. So I want the slope of this line. It looks to be up 1, 2 over 1, 2, 3, 4. So it looks to be 2/4, which of course is just a number 4. So that's the value of our derivative there. These are called, we call these sometimes analytic derivatives. You're going to get the derivatives from a graph where they're going to give you some information from them, okay? You got to know how to do these. So let's try h prime of 8. Well, we already got the derivative, so that's just going to be f of 8. Look, don't tempt fate. G prime of 8 plus, check the garden, I guess, gate, plus f prime of 8. So remember, I want the value of f at 8. So here's 8. Here's 8 right there. So the value of f at 8. I look up, it looks to be about 6. G prime of 8, there it is, it's the slope of this line. It looks to be down 1, 2, over 2. So it looks to have a slope of -1. G of 8, the value at 8, go over, it's 3. And I want the slope of f at 8. That's the slope of this line right here. So it looks to be at 1, 2 over 1. So it looks to have a slope of 2. And you can leave it like that, but if you clean this up, you get 0. Now this is very interesting. Take a look here. This is a critical number. That's a critical number for h of x. Even though we can't see the graph of h of x, we know at 8, at x equals 8, h of x has a critical number. In other words, it has a horizontal tangent. It could look something like this. So even though we can't see the graph, we can explain a lot about it. Alright, so number 3 says let j of x equal f over g. So this is going to be, of course, our quotient rule. So we need j prime. So I'm going to go ahead and do that. J prime of x is low g of x times the derivative of the top, f prime of x, minus, be careful, minus the top function times the derivative of the bottom function, all over g of x squared. And I'm just going to plug it in. Oh, that's all I wanted. So there's my derivative right there. Forgot to plug it all in. Okay, so anyways, hope you guys enjoy these videos. Take a look again if you need to, and don't be afraid to ask any questions. Bye-bye.